see this formula for linear magnification in case of spherical mirrors. So what do you mean by the term magnification? Linear magnification is nothing but it tells us the size of the image is how many times greater than the size of the object. So you get a comparison between the size of the image and the size of the object. So this linear magnification you can take it as the ratio of size of the image to the size of the object, and it is represented by the symbol m. So this linear magnification m is equal to the size of the image divided by the size of the object. Alright, so that is equal to, so m is equal to, if you take h2 be the size of the object, then it is h2 by h1. So this is an important relation we have to remember along with the other expressions we have learned so far. Okay, so next we'll see how to derive an expression for the linear magnification. So this is the case what we have taken in the previous class. So here this AB represents the object and this A dash B dash represents the image, and of course this is the real image. So we get the expression for the real image now. And as I told you, m is nothing but it is the ratio of size of the image h2 by the size of the object h1. So m is equal to h2 by h1. So here this h2 is nothing but a dash b dash. h2 is here. This is the height of the image. So a dash b dash divided by ab. This is the height of the object. ab is the height. So this a dash b dash divided by ab, even in the previous expression we have seen, from the point of similar triangles we can get it. We can compare the ratio of the corresponding sides. So this is equal to pb dash divided by pb. And what is this pb dash? It is the distance from the pole and the position of the image. So distance between the mirror and the image is taken to be the image distance. The symbol, what is the symbol we are using? That is V. And this PB is nothing but the distance between the pole and the object. So that we know that is actually U. So that distance is U, and the distance PB dash is V. So we can take here divided by that, you can take it as actually U. Right? And what is this A dash B dash? We know A dash B dash is equal to H2 and AB is equal to H1. And when you apply the new Cartesian sign conventions, this AB is above the principal axis, so this distance you can take it as positive, and the distance which is below the principal axis, this A dash B dash is below the principal axis, it is under the principal axis, so that has to be taken as negative. So you can have this expression m is equal to minus h2 by h1. And coming to the symbols of this V and U, V is to the left of the principal axis, so that is also negative, and U is also to the left of the principal axis here, so that is also negative. So you have altogether, you have this expression, so these two got cancelled, so you'll be having this m is equal to minus V by U. So this is the expression for the magnification in case of spherical mirrors. So that m is equal to V minus U is an important expression. Now coming to here, this m is equal to, we got it to be minus V by U, and this m is negative in case of real images, and this m is equal to positive in case of virtual images. So this we have to remember. That is, in case of real image, the image will be formed below the principal axis, so this h2 will be negative. So altogether that term will be negative in case of real images. And for virtual images, image will be formed above the principal axis. So in that case, m will be taken to be positive. And if m is equal to 1, then the size of the image is same as the size of the object. And we know if m is greater than 1, it means the image size is greater than the size of the object, or you can say the image is actually an enlarged one. And if you say m is less than 1, it means the size of the image is less than the size of the object, and in that case you can say it is actually a diminished image, right? Next, coming to the other formula for magnifications, we can express this m in terms of f v also. So we can see how to derive the expressions. Okay, first we know this expression. This is actually the mirror formula. 1 by u plus 1 by v is equal to 1 by f. So this is the mirror formula which we know already. And if you multiply this expression throughout by v, we get v by u plus v by v is equal to v by f. So this term it becomes 1. On coming to the other side it becomes minus 1. So we have, when you take LCM, we have this expression v by u is equal to v minus f by f. But we know for magnification it is m is equal to minus v by u. So when you apply the negative sign here, you get m is equal to f minus v by f. So this is one formula for magnification which we'll have to remember, right? Then coming to the other formula, you can derive the expression of this magnification in terms of u also. So magnification in terms of u, that's what we are going to derive now. So for this, we are taking the same mirror formula, 1 by u plus 1 by v is equal to 1 by f. And here we are multiplying this equation throughout, by u. So you get u by u plus u by v is equal to u by f. So this term becomes 1. So when it comes on the other side, it becomes minus. So u by v is equal to u by f minus 1. So it is u minus f by f, but we know m is actually minus v by u. So we can take the reciprocal of this expression. So we have v minus u is equal to f by u minus f. And as usual, when you substitute this negative sign, we'll be getting m is equal to f by f minus u. So this is the other formula for magnification. So we have this, there are two different expressions. So we know m is equal to v minus u. This is one expression for magnification, and this is m is equal to f minus v by f. So this is also an expression. So when you are given, when u is not given, if u is not given in the expression, in that case you can straight away make use of this expression. The same way if v is not given, so in that case we can make use of this expression straight away. These two are the shortcut forms of the mirror formula. You can make use of them too.